All right, let's go ahead and take a look at another argument here of predicate logic, and we'll decide whether we want to try to build a counterexample or whether we want to try to do a derivation. So it says that something is f or g, and everything, if it's f, then it's h, and if it's g, then it's h. Therefore, something is h. And, that sounds right. Like this thing, whatever it is, it's f or g. If it's f, then it's h. If it's g, then it's h. So something's got to be this thing, whatever this is, has got to be h. Okay? So something is h. All right. So let's try to get a derivation here. If that doesn't work, we'll try to get a counterexample. So this is what we're trying to prove. All right. So the first thing I want to say is we're going to have to do eliminations on all of these. Okay. Anytime you have existential and universals, you want to make the assumption that you're going to use for the existential elimination first. All right, and the reason for that is because when you do that, you're trying to get a letter that's new to the proof, or you need to use a letter that's new to the proof. So, for example, if we did this first, say we got FB, therefore HB, and then we started our existential elimination, and we have to use a new letter, right? So, I don't know, let's say we used C. Now, we can't use these two things together, right? These are different, these are all different formulas. And we would wind up having to do universal elimination again here with a C, which is okay. We can do this as many times as we want, but we would wind up with a much longer proof than we want, right? So do your assumptions for existential elimination before you do the universal elimination steps. So what we're going to do, looking at this formula here, we're going to start an assumption. We're going to start a subderivation for existential elimination. So again, we know that something is f or g. We're just giving it like a label so we can reason about it, and then we're going to get rid of that at the end. So what we're trying to get in here, of course, is just this. We're trying to get there is some h. That's what we're trying to get out of this subderivation. And of course, we can get this if we can get HA. Okay, we can just use existential introduction on it, which is a rule that's really easy to use. There's like no restrictions. So what should we do now? Anytime you kind of don't know how to proceed, something you can do is just go ahead. It's kind of like unpacking your premises. When you're doing sentinel logic, you can start taking your quantifiers off as much as you can. All right, so let's take the quantifiers off and see if we can see what to do. So we get FA, therefore HA, GA, therefore HA, okay? And those are universal elimination on 2, universal elimination on 3. And again, we could have used any letters we wanted, but we want ones that are going to go with what we already have here, so we can work with these together. And we could do this again. We could do this as many times as we wanted. Like we could put a line 7 in here, D, therefore HD, or whatever. You can use universal elimination on the same line as many times as you want. There's no restrictions on it. That's just not going to really move us forward in this proof. So let's not do that. Okay, so what we should do here, now this is, this is just a simple derivation now. There's no more quantifiers left to work with. So we can use just junction elimination, right? And these will be pretty short. We're going to show that FA leads to HA, and we're going to show that GA leads to HA. And fortunately, there's really nothing to that, which is good because I'm running out of room. So if we assume FA for purposes of just junction elimination, we get HA right away on line 8 by conditional elimination, lines 5 and 7. Okay, line 9, we're going to assume GA for disjunction elimination. Okay, and we get HA on line 10 by conditional elimination, lines 6 and 9. So now we get this goal we wanted. This will be our line 11. Disjunction elimination 4, 7 through 8, and 9 through 10. Okay, now we can use existential introduction on line 11. That'll be our 12. Okay, because if A is H, then something's H. And now we can, we've met all of our restrictions, right, for using existential elimination. This was a letter that wasn't anywhere in the proof above it. And we can go ahead and pull this out of here because it doesn't have the constant that we started with anywhere in it. So 13 by existential elimination, line 1, and then 4 through 12. So I'm sorry about the spacing got away from me a little bit here. This is kind of a wobbly proof, but there you go.